Hi there guys, we're going to work on confidence intervals, but before we do that I want to start with a non-statistical example that I think will help in understanding what's going on here. So on the screen what I have here is just a simple map of a neighborhood, and some areas of interest I want to point out is right here we have the school, we have a movie theater, church, post office, stores, and a neighborhood. Now right here, this is Bobby. And Bobby lives in this house right here and goes to school here. And we have a goal for the day. Our goal is going to be to, given some information, is to locate where Bobby is. So our goal is to locate Bobby. But we're not given much information. Some of the things we know is that Bobby is a school-aged child. So Monday through Friday, he goes to school. On Sundays, Bobby attends church. And usually on the weekends, on Saturdays, Bobby likes to go see a movie. The only other information we're given is that it's noon. We're not told what day of the week it is, we only know the time. So given that it's noon, our goal is to guess where Bobby is located. Now our first and most logical guess would be to guess that Bobby is at school. This is because Monday through Friday around noon, that's where Bobby would be. But I think we can all agree that Bobby is not at the school all of the time when we know that it's noon. So let's kind of draw a circle around the school, and we'll say we're 80% confident that Bobby's there. Because like I said, we know on the weekends he's not at school, or if it's during the summer he may not be at school, or it could be a sick day. So we're not 100% sure, only given that it's noon, that Bobby is in the school. Now let's say we want to be a little more confident about our guess of where Bobby is located. So if we want to do that, what we can do is extend that circle to encompass the movie theater and the church. So this now covers most days where Bobby is. This will cover most Saturdays around noon he's here, Sundays around noon he's at church, and then when school's in session, he's at the school. And notice what we did here, our best guess, which was the school, we're still going to keep that at the center. We're just going to expand the area outward to try to figure out where Bobby is. So now we'll say maybe we're 90% confident that given the information that it's noon, Bobby is somewhere in this area. Now let's say that I want to be even more confident. Well, we do the same thing again. We extend the circle out. Once again, still keeping the church or the school at the center. And now what we can do is we've got the neighborhood in here. Maybe he ran to the post office for his mom. We've got the store. So now we're 95% confident that Bobby is in this area. And then finally I can extend it out to include the entire map. And if I do this, now we've included Bobby's house. Extending this out, we're now 99% certain that Bobby is somewhere in this area, given that it's noon. Notice I didn't go 100% because Bobby may have left town. Maybe he went to go see his grandma. You know, we're really never 100% sure where Bobby is, but given the information, we're pretty confident that somewhere in this giant circle, Bobby is located. So before we get really started talking about statistics, let's see what we noticed here. The first thing we noticed is we kept our best guess at the center. In this case, that was the school. And the second thing we noticed is if we wanted to be more confident where Bobby was located, we had to make that circle around him larger. So we made the circle bigger circle went up, the more confident we are. And the third thing, at some point, once the circle became huge, it wasn't as informative anymore. And this is because, look what happened here. When we wanted to be 99% certain of where Bobby was located, we actually had to include the entire map of the neighborhood, so that really didn't help us narrow down where we thought he was located. Whereas when we just had the circle around the school, we had a very narrow location, but we were only 80% confident that Bobby was in that particular location. Sorry about that. So over here for number 3, we have a huge circle. Well, what that means, once the circle became huge, it was not as informative. So keeping this idea of trying to locate a child in a neighborhood and drawing circles around it to encompass more and more area, we're going to use this idea to explain what a confidence interval means in terms of statistics and parameters. So just like with the, well, let's first talk about what is our goal in statistics. What are we trying to do here? Well, there's a reason the field of statistics is called statistics, and that's because we use statistics, which I realized that was a mouthful right there. But what we talked about earlier is you have a population, and usually that population is too large to measure everyone or talk to everyone or look at everything, but from a population you get a parameter. Notice both of these start with P, and then from a sample you get a statistic. Now the overarching goal is we really want to know that parameter. But unfortunately, since the population is so large, we're not able to know the exact number for the parameter. So what we do is we estimate it with the statistic. And that's where the field gets its name from. So above, when we were talking about Bobby and where he was located, our best guess for him was the school. So we put that right at the center of our search. Well, that's what we do here. Our goal is to find the parameter. But since we don't know the exact number for the parameter, the statistic is now our best guess. So what we can do here is we'll draw a little dot, and we'll say that this dot is the statistic. And if I want to guess the parameter, what I can do is draw a bubble around my statistic and say, well, I know the exact statistic is not the parameter, and we know this from sampling variability because from sample to sample that statistic is going to vary. But if I draw an area around the statistic, I would anticipate the parameter to be somewhere in this area. And we call the width of that bubble, that's what the margin of error is. So looking at the formula for a confidence interval, remember that the formula for the confidence interval is the statistic plus or minus the margin of error. We can see this looking at this picture because we have the statistic right in the center, just like we had the school in the center when looking for Bobby. And then the width of this bubble or this circle around it on either side is the margin of error. So we have the statistic plus the margin of error to get the right side, and we have the statistic minus the margin of error on the left side of the bubble. Now what will happen is, just like the map with Bobby, when we wanted to be more confident that we actually captured his location, we do the same thing with confidence intervals. We continue to draw larger and larger circles around the statistic, each time increasing the margin of error to be more and more confident. So if we wanted to put some numbers to these things, we could maybe say that this one right here was a 90% confidence interval, maybe this one was a 95, and this one is a 99. So once again, as the confidence goes up, sorry about that, the margin of error is also going to increase. And that's because we have to expand that circle. Sorry. Here we go. Margin of error also goes up because we have to expand that circle to be more confident that the parameter is somewhere in the bubble. Another thing we have to be careful about, well, actually, before we do that, let's first give an example here. Let's say we have a man, draw a little stick figure here, and this man has ducks. He's an industrial duck farmer. And unfortunately, his ducks have come down with a disease, so his ducks not feeling so well. But the disease that they have to actually kill the duck to be able to diagnose them. So he can't go out and test all of his ducks, otherwise he would have to kill them all. So instead what he's going to do is he's going to take a sample. So let's start out with what is his goal. His goal is to find the percentage of all of his ducks that have disease. Percent of all ducks with the disease. And remember that this percentage, the one that he's looking for, that's the parameter. So since he can't kill all of his ducks, what he does, he takes a sample of 100 ducks. And out of those 100 ducks, he finds that 10% have the disease. Now this 10%, that's the statistic. And we're going to use this statistic, oops, spelled that wrong there, to estimate the parameter. So if he wanted to create, let's say, a 95% confidence interval, what he would do is he would start with his statistic, which is the 10%, and then he's going to add and subtract from that the margin of error, so MOE. Now I'll kind of come up here and write, remember, for a 95% confidence interval, the margin of error is equal to 1 divided by the square root of n. N is always the sample size, so we have 100 ducks in our sample. So margin of error equals 1 divided by the square root of 100, which equals 0.1 or 10%. And so I'm going to come down here. So what this really is this is going to be 10% plus or minus 10%. Now be careful when writing your confidence statements like this. You want to either have these both be percents, or alternatively I could have wrote this as 0.1 plus or minus 0.1. You just either have to use both of them as decimal points or both as percentage. It doesn't matter which one you choose. So what we have here now is a confidence statement, or if I wanted to go and write this as an interval, what I would do is I could alternatively write this as 0%, that would be the 10% minus 10%, comma, and then 10% plus 10% is 20%. So this would be his 95% confidence interval as far as how many of the ducks have the disease. And there's a couple things to notice here. Notice one thing, we only get an interval out of this method. We don't get an exact number for the parameter, and we never will. We only get an idea of where the parameter may be. Now the next thing we need to talk about is what exactly does a confidence interval mean? Because there's a very specific meaning that goes along with it. So let me get a blank page here, and we'll talk about what does it mean when we say confidence interval. Okay. So starting here, what does confidence interval mean? referring back to the ducks, so what we had was we had our first sample, which was the 100 ducks where we got the 10%. From that sample, we got a statistic, which was the 10%. And using that statistic, we created a confidence interval. Now let's say that we repeat the process and we start over. So now we take a completely new sample, still coming from the same population, just a different sample. And from that sample, we get a statistic. And remember, because of sampling variability, these are going to differ. But around that statistic, I create another confidence interval. And let's say I continue this process until I've collected 100 or 1 million samples. And then from my 1 millionth sample, again, I find a statistic. And then from that statistic, I calculate a confidence interval. So notice what we have here. We have a long list of confidence intervals. Each one of these is different because we restarted the process each time. So I have 1 million different confidence intervals here. Now, if every one of these confidence intervals was a 95% confidence interval, what that means is that we would anticipate 95% of the list of the confidence intervals to contain the true parameter. So out of these 1 million, only 95% of the intervals that we made here are actually going to contain the parameter. And that's what the interpretation of a confidence interval really means. So a couple things to note here. Notice that if we're only 95% confident, that means that 5% of this list is not going to contain the parameter. So 5% of 1 million, that's pretty many confidence intervals that are not even going to have the parameter in them at all. And then the other thing to notice here is, once again, we never get an exact number for the parameter. We only get intervals, and we're just saying that 95% of these intervals contain the parameter. We don't know what that parameter is. We're just getting a better idea of where it's located. Just like when we were looking for Bobby on the map, when we were 80% confident, we had that circle around the school. That meant, he wasn't necessarily in the school, but that was just our really good guess. And that's what confidence intervals do for us. They put that bubble around a statistic and just give us a really good guess of where the parameter could be. So, earlier in our example, we had a 95% confidence interval, which was 0% to 20% that we calculated. So let's say that the farmer goes kind of crazy, and he decides that he goes ahead and he kills all of his ducks. And when he kills all of his ducks, he actually finds that 23% of them had the disease. So the question is here, did we do something wrong? Because if he kills all of his ducks and he finds out how many have the disease, well, that means this would have been the parameter. But notice that the parameter is not in that confidence interval that we built earlier. So would that mean that we did something wrong? And the answer here is no. Because like I said earlier, remember, if you're only 95% confident, that means that 5% of a long list of intervals are not going to contain the parameter. So this interval right here must have been one of that 5% that did not contain the parameter. So just to kind of recap here, our goal, or what we're trying to do, is we use that statistic to estimate parameters. And one of the ways that we do that is we build a bubble around a statistic, and this big bubble, we can think of that as the confidence interval, and the width of that bubble on either side, that's the margin of error. So notice, the more confident we are, the bigger the bubble has to get. Therefore, the bigger the margin of error gets, because we're just more confident that the parameter is somewhere inside that bubble around the statistic. But our actual interpretation, like if we're going to put it into words of what a confidence interval is, that's when we start talking about long list of confidence intervals and what percentage of that list is going to contain the parameter. At no point do we actually place a number on the parameter unless we were able to go and look at the entire population. So in the case of the example, if he went and killed all of his ducks, then yes, then he would be able to actually go in and see how many of his ducks had the disease. So that's all I have now. I'm brand new working with this software, so let me know if this worked for you, if I can do something better. I'm going to continue to try to play with it, that way I can give you guys some more examples as we go further in the material, because it's going to get a little more challenging.